we're going to finish this section by doing 2 word problems. And so the idea here is that you've got to read the word problem and figure out, is it a GCD type of word problem or is it an LCM word problem? And we're going to kind of pick apart the wording and see if we can figure it out. So the first one says, Anna has made 42 chocolate chip cookies and 54 sugar cookies. She wants to divide them, take out that word put. She wants to divide them into bags with the same combination of cookies in each bag with no cookies left over. So she wants every bag to be identical. They all need to look the same, and each bag has the same number of chocolate chip cookies and the same number of sugar cookies with no cookies left over. What is the greatest number of bags she can make? That word is a hint. The greatest number of bags. She's not going to make more cookies, right? The question's not like how many more cookies would she have to make. She's trying to divide these into bags. We're trying to find the greatest number of bags. So it's division, and it uses the word greatest. This is greatest common divisor. That's what they're asking you to find. They're asking you to find the GCD of 42 and 54. And throughout this section, you've learned a whole bunch of methods for how you can find it. So you can use prime factorization, you can do division by primes, you could draw a Venn diagram. There's a lot of ways to do it. I think for this one, I'll do prime factorization. So 42 is 6 times 7, 6 is 2 times 3. I'm just going to knock out some quick little factor trees. 54 is 2 times 27. 27 is 3 times 9. 9 is 3 times 3. So 42, remember, put them in order, low to high. And you would be looking for the common factors, right? The greatest common divisor. So look for the common factors. So we have a 2 that's common, and we have a 3 that's common. And so we would multiply those together, and you would get 6. So the biggest number that will divide into both of these is 6. What is the greatest number of bags she can make? It'll be 6 bags. But let's go a little further. Each bag would contain, let's talk about how many cookies would be in each one. If she's going to make 6 bags, you've got 42 chocolate chip cookies. If you divide that into 6 bags, you're going to have 7 chocolate chip cookies. And how many sugar cookies would each bag have? You've got 54. You're dividing it into 6 bags. You'd have 9 sugar cookies. I know it didn't ask for this last part. It just asked for how many bags. But I think it's helpful to know, and as teachers, you're going to have to be like divvying up classroom supplies all the time. So this is actually kind of a thing that you might use. If you're trying to find the greatest number of bags she could make, it would be 6. And then this tells you how many would be in each bag. So it's a GCD problem. That's the takeaway. Let's look at this problem. 3 motorcyclists ride around a circular course starting at the same place at the same time. So they're riding in a circle, right? So they're starting here, they're going around the circular path, just over and over and over and over again. They're going around. The first person passes the starting point every 12 minutes. So they're going around, it's a 12-minute pace around 12, 12, 12, 12. The second person passes the starting point every 18 minutes. So they're going a little slower. It takes them 18 minutes to get all the way around. The third person passes every 16 minutes. After how many minutes will all 3 pass the starting point again? So the idea is to consider what's going on here. They're going around this circular course again and again and again, multiple times. They're going around and around and around. We're trying to find out, when will they all line up again? When will 12, 18, and 16 all line up again? That's an LCM question. So they're asking us for the least common multiple, and it's of 3 numbers. It's 12, 18, and 16. So if you have to do an LCM for 3 numbers, you either have to do prime factorization like we did here, but you'd be comparing 3 lines and you'd be looking for the common factors in all 3. Or you could use another method. I actually prefer the division by primes method for LCM. So I'll go 12, 18, 16, or you can put them low to high order if you want to here. It doesn't matter. What's a number that will divide into all 3 of these? Well, they're all even, so 2. 2 divides into 12, 6. 2 divides into 18. 2 divides into 16. Is there a number that will divide into 6, 9, and 8? No, I mean there's 2 will go into 6 and 8, and 3 goes into 6 and 9, but there's not one that goes into all of them. So it turns out that if you hook like an L shape, that's how you get your LCM. So you do 2 times 6 times 9 times 8. This is going to be a pretty big number. Let's see what we get. 2 times 6 times 9 times 8. 864. So the LCM is 864, and this would be minutes. It's going to be 864 minutes before they pass all at the same time. They'll all meet up right there. That's a really long time, by the way. 864 divided by 60. That's like 14 and a half hours of riding on a motorcycle. I don't know how realistic that is, but it would be 864 minutes. You could write out the multiples, but I think that takes way too long. I think if it's LCM, this is the most effective method, especially if there's 3 numbers. But again, you could have done prime factorization if you wanted. If you did a Venn diagram, you'd have to do 3 circles, and that would get a little bit tricky also. So that's why I often use this method. I always fall back on this method because it works all the time. So GCD word problem and an LCM word problem.